From SigOpt, an Intel company, I'm Mike McCourt, and this is Experiment Exchange.
I basically try to build solutions so that we can prevent bad guys from stealing money from us, right? That's my goal.
Today, we have with us Venkatesh Ramanathan, Director of Data Science at PayPal. His team's focus is on identifying and preventing fraudulent PayPal transactions. We first discuss how the development and application of machine learning models has evolved over the past 25 years, from his time using naive Bayes at AOL to his work with graph neural networks at PayPal. We dive into the importance of robustness in deployed machine learning systems, the role that graph neural networks play in pursuit of robustness, and the difficulties still present in deploying graph neural networks, such as scaling to bigger data. We also discuss the need for sample-efficient hyperparameter optimization using tools such as SigOpt. Ladies and gentlemen, welcome. Today we have an outstanding session with Venkatesh Ramanathan, Director of Data Science at PayPal. Sir, thank you very much for joining today.
Thank you for inviting me. Pleasure to be here.
Absolutely. So please tell us a little bit about yourself and your history.
Yeah, I have been in the industry close to 25 years. I started out as an engineer, computer science background. I spent about 15 years building large-scale backend systems for, I don't know how many of you know, but one of the biggest internet service provider called AOL. So I spent quite a bit of time there, and after pursuing my PhD in computer science, I started interested in the machine learning space. So with AOL and now about 9 years at PayPal, currently I'm working. I've been spending a lot of time in AML side of things. So mainly doing a lot of applied research and focusing on variety of problems, mainly around fraud. I basically try to build solutions so that we can prevent bad guys from stealing money from us, right? That's my goal, and using AML technologies to facilitate that.
That's a very valuable goal. I think very important goal. I certainly like when there's no fraud on my PayPal account. Yeah. You mentioned I'd like to follow up just briefly there. So you say you've been working at AOL back in the day also. Obviously, I used AOL plenty back when I was a bit younger. Was there any AI ML going on at AOL while you were there?
Oh, absolutely. I think we started mainly around email side of things, and anti-spam and anti-phishing domain. We employed some of the NIE-based classifiers back in the days, long time ago. All the spam detection was done. So the machine learning space has evolved, right? Right now, it's all about deep learning. But prior to that, all this traditional machine learning tech like Bayesian classifiers was widely used and very successful. In fact, even my PhD, which I was more applied in research, I took most of my PhD work back into AOL for productionizing some of the emails fighting spam and phishing systems. So yeah, it's very heavily used.
That's a really amazing journey and evolution that we're seeing here over the years. The naive Bayes being used in email for the email spam detection, and now you're pushing into new fields in the fraud detection as well. Can you talk a little bit about that evolution, about how the community at large has evolved and changed over the years, and in particular what you're embracing today at PayPal?
Yeah, certainly. I think what fundamentally has changed the scale of the data we are dealing with today is significantly much higher than those days, right? So, which imposes a lot of challenges from having the right infrastructure to scale, right framework to scale, and right tools like SigOps, hyper optimization as for scaling, right? So, all these things you need. So you need to have scalable infrastructure from the ground up to facilitate building machine learning models to build robust machine learning models, right? So because one of the things which deep learning throw light to us is that if you have large amounts of data, you don't need a very complex technique, right? So by applying appropriate toolkits, you can build a very robust model. So that's fundamentally a changed from those days to here.
Hmm.
And a lot of other things which have changed is that we used to do a lot of human-based feature engineering, and right now it's more and more is learning-based feature learning as
Hmm.
opposed to human feature engineering. That's fundamentally a revolutionary change from those days to now. So
That's a very good point. Keying in a little bit on that, this automation of feature engineering, or maybe features motivated by things that humans weren't thinking up. How has that changed the field? How, in particular, I'm wondering, can you comment at all about how that's changed models, both from the perspective of robustness? You'd mentioned robustness being important, but then also interpretability.
yeah, so interpretability is one of the thing we lost. Actually, I would say from the traditional days to now is with an eye-based classifier. You can look at the weights of your features. It's much easier to interpret compared to the deep learning side of things, right? So
Hmm.
yeah, when we started pushing for more and more model accuracy, model robustness, we lost interpretability in the process. So I am really glad now that academia and the researchers are massively focused on not just provide. There are interpretive techniques. So given the deep learning is providing all those robust models, you can have a post hoc, ad hoc, after model interpretability components built onto the, you know, deep learning models, right?
Hmm.
Personally, I don't believe that's the right approach. Interpretability has to be built from the ground up, right? So instead of having a interpretability as an ad hoc process, right? So there are a lot of work which is being done. One of the things which I am passionate about is the graph based machine learning. So graphs representation in general is much more interpretable compared to non-graph data, right? Because in graph, for example, you can walk the edges. So how far you are from your somebody who is sending money to you, you can walk the edges of the graph to figure it out, right? So the
Hmm.
graphs in the representation itself is
I see.
interpretable in
That's a
that
very
sense.
interesting point. Could you dive a little bit deeper? And in particular, maybe all of our audience isn't familiar with this graph neural network topic.
Yeah, so essentially, graph neural network started with how can we facilitate deep learning, deep neural network based architecture to a graph structure, graph representation. So essentially, the idea it takes off is that you can approximate individual, let's say, accounts represents vertices in a graph. You can know more about particular specific accounts by looking at your neighboring accounts, right? How can we approximate, aggregate information from your neighboring nodes to say something about yourself, right? Because
Hmm.
you are actually who you are communicating with, who you are connected to, is kind of a representation of some way to describe who you are in the system, right? So graph neural network lets us actually to exactly apply neural network based techniques to do exactly that. So describe each accounts or each nodes in a graph to say something about yourself. So
Hmm. Hmm. Makes a great deal of sense. You talked about robustness. Would you say that these graph neural network methods, do you feel that they're robust today? Do you think they've built up the necessary amount of robustness to be trusted, pushing things into production?
certainly it's robust, it's interpretable, but I would also want to take some of the problems are better, can be solved better, or you can even can be solved only if it's represented in graph form. For example, with a massive explosion of the crypto
Hmm.
currency and blockchain infrastructure, right?
Hmm.
That those kind of application has to be started as a graph first application, in my opinion, because those are all actually graph to start with. So if you try to start putting the data in a massive unstructured data store like Hadoop,
Hmm.
or in a tabular data structure like MySQL or Oracle, you are not going to have any intelligent insights from that. So some of the newer emerging technologies and applications are better solved if it is represented as a graph to start with.
That's a fantastic point there. That in particular, yeah, we have the blockchain, and obviously beyond just cryptocurrency. Now we're also seeing the NFT explosion. Do you have any other examples of logical situations where graph neural networks should be one of the key building blocks for inference and for decision making?
Yeah, so certainly I believe I work on a lot of the fraud on the fraud domain. Clearly, that anti-money laundering, how actually bad guys move money through our network. You can say it is a network problem, right? So the only way you can solve better is by representing that transactions in a graph, right?
As
Whether
a
it's a bad
network,
guys,
yes.
right, as a network. So that's
Yes.
a classic example.
Hmm.
Besides fraud, the recommendation ecosystem is also better, can be better solved if it's represented as a graph. Um, but one of the challenges, actually, of I would say the practical challenges of making graph to start with for solving some of these problems is scaling graphs is not as trivial compared to scaling non-graph. So there is still a lot of work which needs to be done. I personally believe that the entire infrastructure, like for example, hardware needs to be optimized, which has to be specialized for solving graph processing problems. The software framework needs to be specially adapted. The deep graph library, which I think somebody is going to represent in the panel today. So, those kind of frameworks need to be optimized, and it has to have a special implementation for solving graph specific problems. So unless and until we have the entire ecosystem set up, we won't be able to solve practical problems, right? So we are not there fully there yet, but yeah.
That's a fantastic point, is that it's going to take software work, it's going to take hardware work, it's going to take
Correct.
algorithmic decisions, and it's going to take people buying into the
Correct.
idea of, hey, solve these with graph neural networks. That's a good
Yeah.
call. Well, along those lines of all the pieces that are required to make graph neural networks useful, you mentioned earlier hyperparameter optimization. How does a tool like SigOpt play a useful role in the development of these tools?
Yeah, so when we start building models, there are lots of parameters which needs to be estimated, and a lot of knobs which requires manual tuning, right? So the SigOps toolkit, what it provides is to try to automate it, because it's, first of all, there are too many parameters which human cannot actually explore all the setup parameters manually. It's going to take days and months for somebody to build a robust model. So that's one thing, is certainly to automate some of those choosing what's the right parameters you need for building a specific model. It's trying to automate this. SigOps plays a key role. And one of the other things is it is intelligence built behind in finding those optimal setup parameters in a much more intelligent way, much more robust way, is what SigOps provides. So even if a human has unlimited time, humans still won't be able to find those setup parameters. So the traditional way to find these parameters, like the grid search and all those we're exploring all kinds of unneeded parameters which are not going to help us in
Mhm.
building a robust model, right? This actually narrows down on the specific set of parameters which are more optimal for the problem we are trying to solve. So
That's a very good point, and I think as you talk about building things robustly here, that idea that you incorporate that into your hyperparameter search process, your decision making process, is
yeah.
key to making sure the resulting model is robust, is trustworthy.
Correct.
Would you say so? In particular, one of the things I think we work on often at SigOpt is being sample efficient. So some of it is moving beyond the grid search, breaking free of the grid, so to
Mhm.
speak. But then the second element there is really trying to be as sample efficient as possible. Not just not being at 10 to the 50 or however many points you'd need on the grid, but trying to even be better than that, be on the order of 100 points, couple hundred points, to be able to trust the results that you have. How important is sample efficiency to you in your development of these networks?
Absolutely. I think one other thing with the scaling is that you need to have effective sampling strategies which are intelligent. So I will give you you all know the fraud problem is highly unbalanced. The number of bad guys in the system is less than 1% of the entire ecosystem, right? So when you have highly unbalanced problem, that's where the sampling is even more critical. Is that you need to have a sampling which are effective and intelligent to have you have a representative samples. Otherwise, you're not going to build scalable models, right? So that's where I think SigOpt's way of effective sampling strategy helps with basically narrowing down again optimal set of parameters which are needed instead of having to search through space where you're going to be there endlessly but not going to result in a robust model.
That's good to hear. That's good to hear. Yeah, and I think I agree with you that in these class imbalanced circumstances, they do need to be treated with more care in order to reach the accuracy that you want without ignoring the key class you're trying to identify, which is, as you've mentioned, maybe 1% of the total class present. Great point. So tell me then, we've got 2022 kicking off now. What is important? What should people be looking forward to from your group at PayPal in the coming year? What are you guys working on right now?
Yeah, so without going into the details of what we are working on, but essentially the payment space is evolving significantly. One of the thing is, as you know, that PayPal, we have successfully launched pay with the crypto options. So being able to lot of tools and ecosystems and protection in place for the traditional domain may not serve well in the crypto domain, right? The crypto is designed with anonymity as a first class citizens. Still, it's not fully there, but in the sense that the same tools and ecosystems and machine learning framework won't apply in when you're trying to combine the cryptocurrency, digital currency with traditional payment domain. So that's something is huge for us, actually being able to provide both the options so that the customers have a choice in picking the right payment option, and being able to, and that also opens a door for bad guys to exploit the system. So building systems which are robust too. So that's some big initiatives we are taking. Besides that, on the technical side of things, certainly I think I am firm believer in building a large scale machine learning systems to do variety of problems, not just to PayPal, but advance the state of the art in terms of research going forward by providing more. Academia is focused purely in small scale problem of research in nature. So my goal is to make those systems scalable and find more practical uh, graph neural network variants so that it can solve. For example, one of the thing I'm working on spatiotemporal GCN, right, is a graph convolution network, because graphs changes with time and also in space, right? Being able to model both time and space simultaneously will help solve some of the problems which won't be possible in a traditional domain. So a lot of exciting things on the algorithmic side of things, and but more importantly, I do believe that we are working with vendors to make sure that the hardware is scalable to meet the large scale scaling of graph neural networks for next 2022 and beyond, a few years and beyond. So it's a long way there, but that's something which we are firmly pushing industry to make a significant dent into that
Yes.
space.
And I do know that at Intel, there are discussions, there's work being done to address exactly these concerns. In fact, I think you'll hear some of that if you go to summit.sigopt.com. There'll be some content there talking about that. definitely is an exciting push going forward. One minor follow-up I'd like to make there. You talked about a bit of a gap sometimes between industry and academia, and some of this is natural or logical. Academics, from a research perspective, need to work on problems that are tangible enough, and also problems that can be published, or else it's going to be hard for them to get credit for working on it among the community. I'm wondering in particular, though, stepping away from research for a moment, if you could give some advice to students, whether it be undergraduate students or graduate students in different fields, or maybe in a specific field that you're thinking, if people are interested in joining your team, what should they be doing to prepare themselves, to have the right skills, the right know-how, the right perspective, to be a successful contributor as a data scientist on your team?
Yeah, so I think there is we need a much bigger curriculum around the AI/ML space. So most of the academia is mostly around the research side of things, but there are no way whether which particular solution is. They're always looking for the newer and the greatest thing, but that may not be practical, right? So I think one of the advice I would give for students is build solutions which are practical in nature. If it benefits you in your daily life, whatever you're building, then that's going to be beneficial for lots of other people too, right? So that's something to think about, is that when you're trying to when you're on the research side of things, making sure that whatever you're building, it could focus on simplicity, which are more useful rather than building something very complex and not useful to many, right? So that's something I would say. And there are I think some universities have a good data science program, so which actually has more of a practical feel to it, so but not universities have that. So I would say that if you don't have that, take some certification. But the beauty of these being in the data science AML space, regardless of what your undergraduate major is, right? It gives you an opportunity to be in this field, because this field is looking for interdisciplinary field, not one cookie cutter or just computer science or just electrical engineer, right? So
Mm-hmm.
people with any kind of major can get into this field if you have that inclination and the intuition to learn, right? So this
Great point.
is a massively interdisciplinary field. Our group is filled with people from all kinds of background, not just one. So which is what we need to build next generation of data science AML solutions. So
That's a fantastic point. I love it, and I love that message, and I definitely want to send that out into the ether that that anybody can be doing this work. There's a set of skills that are required. You need to know some software, you need to know some statistics, but your background doesn't need to be PhD in computer science. It could be a lot of different things, and you can make a difference right now.
that's
Excellent. Excellent. Thank you very much for joining us, Venkatesh. It's been an absolute pleasure talking with you today, hearing about the evolution of ML and the importance right now of graph neural networks.
Thank you for hosting.
Absolutely. All right. Everybody out there in the world, thank you for joining, and we'll see you next time. If you have enjoyed these interviews and want to learn more, the description below contains the link to the show notes. There you will find links to the papers we reference, supplemental material, and a transcription. We hope to see you here next time on Experiment Exchange.